All right, all quizzes turned in. Here we go. Here we go. 2.2, this is number 16, page 16. Everybody with me? Page 16. Letter A. Write an equation for the following. Okay, so there are two basic kinds of variation that we are going to be doing. There are more kinds of variation, but we are focused on just two of them. We're going to do direct and inverse, okay? Here are the general formulas that you need to know. Question A, y varies directly as x. That means y equals something times x. Okay, that's direct variation. So anytime you have a problem, and if you look down there, you're going to have some word problems. Anytime you have a problem that discusses direct variation, that's going to be your setup. Now B says they vary inversely. That setup is k over x. This is really, really easy. You just have to remember the setup for direct, the setup for inverse. So then, when I look at letter C, it talks about direct. So something is going to be k times something. That is direct variation. Y equals kx. Only it isn't always y and x. What is it in this problem? P varies directly as q squared. P varies directly as q squared. What is D? D says I have inverse. So inverse is something equals k over something. That's inverse. So what are the somethings? M varies inversely as the sum of A and B. Sum means atom, so A plus B. E is a direct. So direct says something equals k times something. That is your direct variation setup. So what is it this time? Height varies directly as width. Now, F is a different vocabulary word. Proportional is just another math way of saying direct variation. So letter F is a direct variation because it says proportional. So what is my direct formula? Something equals k times something. In letter F, it's y and x again. So the answer to A and the answer to F are exactly the same. Worded differently, but means the same thing. And then, look at G, see the word inversely in there? So what does that mean? Something equals k over something. So what do we got? Rate, I'll just use R, is inversely proportional to distance. So when you do one of these problems, your setup is going to be this or this. Right? That's going to be your setup every time. You're just going to read the question. If it says direct, you're going to set it up like this. If it says inverse, you're going to set it up like this. Okay? Now, we're going to talk a moment about what the difference is between direct variation and inverse variation. I love bananas. Okay, so I go to the store and I buy bananas. The more bananas I buy, the more money I have to pay. Would you agree with that? That's called direct variation. More bananas means more money. That's direct variation. More of one means more of the other. Now, I drive to school every day. If I drive 20 miles an hour, it takes me a certain amount of time to get to school. If I drive 30 miles an hour, it will take me less time to get to school. Would you agree with that? So more speed actually means less time. That's inverse variation. If both things, both quantities, are growing the same way, it's direct. So we had a height and weight example up here. Normally, I mean, there are, of course, exceptions, but normally, the taller you are, the more you weigh. That's direct variation. Does that make sense to you? So if things are both getting bigger or smaller, that's direct. That's direct. If one's going up, like more speed, less time, that's inverse variation. Okay. All right, let's look at a couple of word problems here. Temperature is directly proportional to volume. So which of my setups am I going to use? One or two? One. So I'm just going to write that down right now. I'm going to say, okay. There's my setup. I'm doing problem number 2A. And it says temperature is directly proportional to volume. So does that make sense to you? That right there makes sense. Okay. Now, next part, that's the first sentence. I'll just call it one. Sentence 2 says, if the temperature is 70, then the volume is 30. So you see what I did? I just plugged in the numbers they gave me for my T and my V. Now, can I solve that equation? What does that tell me? K equals what? I'm dividing. Doesn't K equal 7/3? 70 over 30? All right, and then the third sentence, go back to this right here. Find the temperature, I don't know the temperature, when the volume is 20. Now remember, I'm finding temperature, I know the volume is 20, and I already figured out that K was 7/3. So the temperature is going to be 7/3 times 20. So about 46.67 degrees. So the first sentence, I did my setup. In the second sentence, I plugged in some numbers and I figured out what K was. And then I finally got to the question, but I knew K, I knew volume, and so I just multiplied and got my temperature. Am I your hand? Okay. All right, let's look at B. Which setup am I using, number 1 or number 2?
2.
I'm using number 2, so I'm just going to write that down. All right, volume varies inversely as pressure. Okay, does that make sense to everybody? Okay. What's the next sentence say? If the volume is 200, then the pressure is 40. That makes sense, Shan? So what does that mean K is? You gotta be able to solve that. What's K gonna be? K equals what? 8,000. Very good. How do we get 8,000? We took 40 times 200. Okay. So basically now you know this guy right here. You know K is 8,000. Right? So what does the question say? Find the pressure, find the pressure, if the volume is 950, so I'll put 950 here. I don't know what the pressure is, but I know my numerator is 8,000. Now be careful when you solve this. This is going to be a two-step solve. All right? We're going to multiply by P first. So we'll have 950P equals 8,000. You cannot do this in one step. So you're going to get rid of your fraction. 950P equals 8,000. And then divide by 950. And that, whatever 8,000 divided by 950 is, yep, 8.42. So P is 8.42. And there's no unit on that, probably pounds, but I don't know, so I'll see. Okay? All right, go ahead and get out your 2.2 homework. Every one of these problems, you're going to set it up one way or the other. That's it. There's only two ways it's going to be set up. So, which is it for A? This is 1, this is 2. Which is it for problem 1A?
1.
It's this one. So I'm going to write this down. And then I'm going to plug in whatever I've got. So I've got X varies directly as y squared. So what are those in the answer blank? X equals ky squared. Now I always use the boxes. You don't need to. You don't need to use those if you don't want to. All right, what about B? What's B gonna say? Which format? 2. So that's my format. What have I got this time? I've got P varies inversely as Q. So in the answer blank, P equals K over Q. Which one? 1 or 2 for number C? 2 again. So this is going to be my setup. And what have I got? M squared varies inversely as N cubed. So I have M squared equals K over N cubed. It doesn't matter what those things are, so don't get freaked out because it's cubed or something. It doesn't matter. And what does is proportional mean?
Direct.
Direct. So I'm going to have my direct variation and it's C and D, so that's it, just C equals KD. That's it. All right, 2A. Which format, read the first sentence. Which format am I gonna use for 2A? 2? So I'm gonna have volume is inversely proportional to pressure. The volume is 60 when the pressure is 15. Does that make sense to everyone? So what do you do now? Pause for a second and do what? Multiply by 15. So K equals, is that 900? And then find the volume. This is your setup now. So we're finding the volume when the pressure is 20. So don't we have 900 over 20? Which we can figure out to be 45? All right, you try that last one on your own. See if you can get that last one done.
Wait, so is the answer volume equals 45?
Yeah. Yep. It's in find the volume, right?
Yeah.
Anybody willing to share your ideas?
83.12.
What'd you say?
83.12.
You are exactly right, Gabby. Give me a second, I gotta get this in the grade book here. And then we're gonna walk through that. Walk through that. So you got exactly. Did anybody else get 83 point? I said 106. She said 0.12. Everybody got that? Good. All right, let's walk through it. So temperature is directly proportional to pressure. So hopefully this is your setup. The pressure is 9.6 when the temperature is 70. So this is a multiplication here, K times P. So what do I do? To find K, I divide by 9.6. So I got K to equal 70 divided by 9.6. 7.29. And then it says T equals, find the temperature when the pressure is 11.4. So remember, you now know K. K goes in there. You know the pressure is 11.4, so we'll just multiply those two things together, and I got 83.106 or 83.12 if you rounded that off. Okay? All right, so don't turn that in. I am going to give credit for that that out, well, you don't get credit if you're here, obviously. You'll want to pull that out and look it over periodically. Since it will be on the test. We will have a problem like that, probably maybe one or two. But that's it for 2.2, so now we're moving on to 2.3, which is a much bigger section. It's easy too, but it's bigger. All right, so we're back in our notes. We're not doing the homework. We're back in our notes. And we are not going to sketch these on our calculators. We are actually going to sketch these awful, yicky looking hard problems by hand. There are two things, actually three things that we gotta know before we can get started. One is you've got to remember your BFFs, okay? If your problem is an x squared, this one is not, but what do we know about x squareds? What do they look like? They're parabolas. So in other words, if I'm pretending I'm a parabola, this is how my arms will be, right? Unless I have a negative in front of me, and then it would be like this, right? Upside down. That behavior, either up, or down, is true for all even powers. So if I had 4 x's or 6 x's, my picture is always gonna start up here, end up here, or start down here, end down here, always. That's what even powers do. All right, now think about x cubed, your BFF x cubed. What does he look like? Isn't he that squiggle? So wait a minute, where does he start? Down here?
No.
And then he ends up ending up here? That's the way odd powers behave. So whether it's a cube, a fifth, a seventh, any odd power is gonna start down and end up. Squiggle around, but start down here, end up here. Unless, of course, you put a negative in front of it, and then what happens? Other way around. It starts up here and ends down here. Okay, we gotta remember that because we're gonna be sketching these by hand. Okay? Next thing we gotta remember is these factors tell me my x-intercepts or my zeros. So without doing anything else, I can tell you that this thing has an x-intercept at -1, another one at 2, and another one at 3. Alright, so where did those dots come from? They came right from the factors. Now, if I were to multiply this all out, and we are not going to do that, but if I were to multiply it all out, how many x's would I have? How many x's do I have? 3. So this is an x cubed. And what did we say about x cubes? All odds start down here and end up here like this. So I know whatever this looks like, it starts down here. So there it is. It starts down this way. That's where cubes start. Now when it hits this point, it passes through, but it has to connect to that one. All these dots are connected, and they're never connected with straight lines. So, you He's coming up from the bottom, he goes through that point, and then he connects to this one. Then he goes through that one, but he can't go very far because he has to connect to this one. And then where does he go? Straight on up, because that's what cubes do. So you just sketch that now, all by yourself. Let's try the next one. Is this one gonna be very similar? Yeah, dots are in a different place. I said dots. The real word for them is x-intercepts or zeros. But you can call them dots if you want. Always label them. Always label them. You okay with that? All right, how many X's do we have? 3. So where do we start?
Bottom.
Down here. Starting down here, coming up to that point. Now when I get to that point, I'm gonna go through it, but I gotta connect it to the next one. So it's gonna go up and connect. Gonna go through that, keep going, and then connect over here. And then what's it gonna do? Go straight up, because that's what cubes do. They start down here and they end up there. Would you say easy enough? Yeah. Now the next one, there's a little bit of a curveball thrown in there. What's going on here? Well, so essentially how many dots am I gonna have on my x-axis? There's only 2. I know that that was twice, but I can't plot it twice. So I have a dot at -1, 0, and one at 3, 0. Now, how many x's do I have altogether? 3. There's still 3 x's up here, wouldn't you agree with that? 2 of them happen to be the same, but there's still 3 x's. So what does that mean? I'm gonna start right down here, because that's where x cubes start. This is where it gets a little different. This point right here was the double factor, right? That's the one that came out of the double factor. When you have a double factor or a squared factor, instead of going through that point, you bounce off of it. And hopefully that makes a little sense to you, because what are you used to? When you see squares, what shape are you used to? Parabolas, right? So this is not an actual parabola, but it acts like a parabola because that is square. Now, it bounces off, but it still has to connect. We don't know how far down it goes, so just come down and go back up, okay? We're not super picky. When you take your calculus class, you will figure out how far down it goes. But right now, we're just coming down and going back up. Now, what do I do when I hit that point right there?
Yeah, sure.
I go straight on through. Wait, Mrs. Ford, why didn't you bounce off? I only bounce off when what? When my factor is squared. Otherwise, I go through. Come on, you gotta admit this is fun. All right. All right, let's start with what we know. Where are my x-intercepts or my zeros? At -3 and 2. x's do I have?
Four.
4. 4 is an even number. And what did we say evens do? Start up and end up. So that means I'm going to start up here. Again, why am I doing that? Because there are 4 x's. And this is what 4 x's look like. Or 6, or 2, or 10. This is what they look like. Now, what am I going to do when I hit this point? I have 2 choices. I'm either going to go through, or I'm going to bounce off. What am I going to do? I'm going to bounce, because that came from this right here. -3 came from this parentheses, it squared, so I'm bouncing off. But I still need to connect to the next dot. Remember, the dots are connected, not with straight lines, but with nice flowing curves. Now, what am I going to do when I hit this dot? I'm going to bounce off again. And that is exactly what I would expect to happen, because what do evens look like? This. With some jiggly in the middle, that's fine, but that's how they start and end. Oh boy. Look at E. So what is the first thing that you should be doing? Putting your x-intercepts on, and where are they? Got one at -1, got one at 2, and got one at -5. Good? How many x's do I have? 5. 5 is odd. Odd does what? Starts down, ends up, right? So I'm going to start down here. Now when I get to my -5, I have to make a choice. I'm going to go through, or I'm going to bounce off. How do I decide? I look at the factor that it came from. -5 came from this right here. No power. So that means I'm going to go through and connect. Now I hit -1. -1 came from here. That has a square. So I'm going to bounce off. And of course connect.
Does it matter which way you bounce off? Like, could you go gone down?
It's coming in from the top, Eli. I'm not passing through.
Yeah, never mind.
All right, now I gotta decide, what am I doing at 2? Bouncing again, which is a really good thing, because I knew I was supposed to be ending up there, and here we are. F. Don't freak out. Is this a little different? Yeah. But don't freak out. You know how to start. What are you going to do first? You're going to put dots at -1 and 3. Then you're going to count up your x's so that you know where to start. So how many x's do I have? 4. 4. See it? 4. That means I'm going to start where? Up here. So here I come. Now when I hit that -1, I gotta figure out what I'm gonna do. Am I going to just zip right on through? Or am I gonna bounce off?
Go through.
I'm gonna just zip right on through. Right? Now here's where we gotta slow down a minute. This guy is Q. Okay? Now, remember how when you have a squared factor, you kinda acted like a parabola? Well, if you have a cubed factor, you act like a cube. So we're not gonna go straight through that, we are gonna do our cubic squiggle through that. So this is gonna look like this. It does its squiggle. And at the time we were doing this with the BFFs, I told you, if you are having trouble drawing that squiggle, all right? You're having trouble. You gotta draw it now, you gotta draw it right. What did I tell you to do? Think about a parabola opening down and a parabola opening up, and then we do this part and this part. And that will give you a nice squiggle every time. All right, so recap. When you hit a point, when you grab it, you hit a point, you have 3 choices. You go straight through, you bounce off, or you squiggle through. And that decision is made by looking at your powers on your factors. All right, G. Where are our zeros, our x-intercepts? Oh, no, be careful, be careful. X-intercepts only come from x's. Does this have an x? So he's not an x-intercept. No, the x-intercepts are -1, +3, and -2. Now, that 2 is not important, but the negative is important. Because what does the negative do? It turns it upside down. So I'm not gonna worry about the 2, but I am gonna have to pay attention to the negative. Dots come from x's. If it doesn't have an x, it's not going to be a dot. Okay? Now, how many x's do I have in this problem? 4. 4 is even. Even should be this, right? But there's a negative in front of it, so it's going to be this. So I'm going to start down here. So there's a lot going through my mind. It's very easy, but there's a lot going through my mind. I have to pay attention to how many x's I have, and then I have to pay attention to that negative. Now, what do I do when I hit that -2? Go right through it and connect. What do I do when I hit that -1? Go right through it and connect. What do I do when I hit that 3? Bounce off. Which is great news, because didn't you tell me it was going to be down, down? Isn't it cool how it all comes together? All right, I need a volunteer to come up and do problem H. Oh boy, this is a big one. Do I have a volunteer to come up with the dots on it? Okay, Kyle, thank you. You can do as much of it as you want. If you want to do the whole thing, do the whole thing.
Alright.
But at least put the dots on it.
That's it.
Okay, so step aside so they can see. So does he have his dots in the right spot? Yep, he's got 3 dots, because he's got 3 parentheses with X's. Okay, what's going on here? Okay, so he says he's starting at the bottom. All right, let's talk about that. Why are you choosing to start at the bottom?
This is a negative.
How many X's do we have?
6.
6 is even. Even should be this. But because of the negative, it's down here. All right, so good choice. Beautiful. What do you think about Kyle's work? No, it's beautiful, it's fine. We don't really need all this, that's okay, you got the right idea there. But notice, even when he drew it, he drew this parabola and then he drew this parabola. And then he went through this one and bounced off that one. That is absolutely tremendous. Does anybody have a question about that? No? All right, I'm gonna stop there because we don't have time to do the next one. And we've packed a lot into it.
I was like,